Problem 3 is kind of the start of the new kind of proofs we've been doing, the ones that are um, less straightforward, more reliant on you providing some information. And this is one we learned in day 45. It's going to use what's called the reflexive property. And we'll get there when we get there. But let's trace out our triangles. We've got this small triangle, EKL, so E to K to L. And that's supposed to be similar to this larger overlapping triangle. Boom, EFG. And here you can see I only have this small side and this larger side. I don't know anything about that base. So I can't use side to side to side, right? Because I don't have that third side. This is definitely going to be a side angle side similarity, but you might be looking at it and saying, well, I don't see anything where they say like these angles are congruent. You don't see any other information they're giving you, nor do they say given anything else. But that's all right. Let's flow with this. Let's go. In the larger triangle, I see that the side that corresponds to 14 is 21, and the side that corresponds to this 28, okay, that is this side, all the way from E to F, and that would be 14 plus 28. That would be what, 42? 42. Yeah, so I've got my sides, and we know that the angle has to be in between the two sides we're using. So the angle's gotta be E in the red triangle. Well, if you look at it, angle E in the red triangle is the same angle E in that blue triangle. They're both angle E, and they're literally the same angle. So you can clearly say angle E must be equal to itself, angle E, and that will be one of our statements. That will be our angle statement. So why don't we just start there? 1. Angle E is congruent to itself. And whenever you want to say that, whenever you want to say something, whether it's a side or an angle, is congruent to itself, or another way to think about it is this angle E is shared by both triangles. Right? Whenever something's shared, that's called the reflexive property. And the one way I think about that, the one way I think about it is it's got this idea of flex. This angle is so flexible, it's an angle in the red and the blue triangle all at once. It's a flexible angle. And that's an angle fact, so I'll keep track of that. 2, I'm going to start doing my ratio of sides. I'm going to do this side. Actually, I'll do the blue first. I'll do side GE. That side is 21, and that corresponds to side EL. And that side is 14. We'll write in that ratio in a second. 3. Do my bigger sides now, from F all the way to E. So F to E, and that side is 42. And that corresponds to this 28, which is side KE. And whatever these ratios are, I know they must be equal in order for the triangles to be similar. So let's do 21 over 14, 1.5. And I bet you when I do 42 over 28, 1.5. If I didn't, I must have added wrong earlier. Well, I must have done something wrong. So we're going to get 1.5 and 1.5. And that's kind of establishing our two other side facts. But we're going to write in what our reason for doing those steps were. Well, we were just evaluating the ratio of corresponding sides. And once I've got this information, right, 1, 2, 3, I know that's not the AS postulate, that's not a real postulate. We'll cover that in the triangle congruence chapter and talk about a little bit more in depth why that postulate, warmly known as the donkey postulate, does not work. We know that is the side angle side similarity postulate. So no matter how you write up the order of it, you always have to refer to it as the side angle side similarity postulate. And that lets me conclude what they asked me to prove, that the triangles are similar, that EKL is similar to triangle EFG. Awesome. See you in the next one.